atomic size, radius, decreases from left to right. So meaning that when you go from left to right, and by the way, of course, there are some exceptions, but we're not going to pay attention to this. The size decreases, or radius, size or radius. Radius is, again, if we consider it a spherical, has a spherical shape, then it has a radius. So again, the size, the radius of the atom decreases from left to right, but as you go from top to bottom, the size increases. Okay, what should I do with this? What you should be able to do with this is, if I give you a list of atoms, you should be able to rank them. Say, you know, this is, let's say, from the biggest to the smallest, so on and so forth. Okay. I wanted to show you a picture. I'll show you two in a second. But how can I just make it more logical or easier to remember? Well, number one is you need to remember one of them, because especially ionization energy is the complete opposite of size. So remember this one, and then you remember that ionization energy is the complete opposite. That way you don't have to remember both. So let's begin. Let's look at our periodic table. Instead of just saying this or that, all of this, and how do I remember from left to right decreases, from top to bottom increases? What we do instead is, what I like to do is say, okay, you start with francium right here. We're not going to worry so much about these. And you draw a line from francium, like here, like all the way to helium that way. And just remember that as you go from francium to helium, neon here, the size decreases. And this actually takes care of both the up, top to bottom, and left to right. Because you know that as you move up, it doesn't matter where, especially, of course, to the right, but even anything above francium is smaller than it. So the size decreases. So that way you can pretty much plot your elements and rank them. So let's look at an example of these atoms. And again, we're going to ignore some of the exceptions, because they can be difficult to account for now. As you go to more advanced chemistry course, you will examine them more fully. So let's say we have the following elements. And the question goes, rank the following atoms in increasing order in terms of atomic radius. Following atoms. So let's rank the following elements in terms of an increasing order, meaning from small to large. That's what increasing means. So from small, this right here, it's from small to large, or from the smallest to the largest. Very well. So you have P, you have Na, you have F, you have K, you have O, and CS. Okay, let's begin. So we know that anything on the right side is small, or the smallest, all the way furthest or farthest to the right is the smallest. Anything to the closest to the left here is the largest. So let's start actually plotting them. So I have P. I'm going to circle P. Here's P. I have Na. I have F. I have K, O, and CS. Okay. So let's see what would be the smallest. We want to begin with the smallest. What do you think is the smallest atom if the size decreases as you move to the right? Well, the farthest to the right is F. So that would be your smallest. It says size decreases. This would be the largest right here. So in this case, we say F is the smallest, followed by, what's closest to the left is O. Then P. Okay, and let's keep moving. Okay, Na is next because size increases as you go down. The closest, again, this is the largest here. So that would be Na, then K, then CS. So the CS is the largest, and F is the smallest. Okay. So let's look at the next trend. Is ion size, ionic size, or radius. So we're talking about an ion, anything with a charge. So X with either a positive or X with a negative. So the trend for this is a little bit more, is a bit, especially when you go across, like from left to right, can be a bit confusing. So what we say instead is the ion of a metal is smaller than its atom, but the ion of a nonmetal is larger than the atom. So what does that mean? So suppose I have Ca, and the ion of Ca is 2 plus. So this is your ion. This would be smaller than Ca. When it loses an electron, it loses a shell, so obviously the size decreases. But if you have something like S minus 2 is actually bigger than S. As you gain more electrons, those are going to repel each other, so they're going to actually move out. So again, this is what we mean by that. Ionic size radius increases from top to bottom, so we still continue with the same thing. Size of ion still increases. So if I go back to this, I'm going to keep this now. Erase all of these. So if I have Ca and Sr, Ca is +2, Sr is +2, then Sr would be biggest or bigger, because as you go down, still the size increases. That is all. Be able to mix those also with atoms. So if I ask you about atoms and ions, be able to apply both trends as well.